Hello and welcome to this week's Solution Saturday. In this series, we'll be focusing on the more difficult questions from the North London Independent Girls' Schools Consortium Group 1 2017 paper. In this video, we'll be going through the solution for question 40 step by step, and hopefully you can see how you can utilise the techniques you've already learnt in class to solve the problem. If you have any questions, then don't hesitate to ping us on Facebook, Instagram, or in the comments section down below. ABCD is a square with vertices at the points with coordinates 0, 5, 3, 1 and 4, 8. Write down the coordinates of vertex C. In this question we've been given a grid, so the first thing we can do is plot the points we already have. You will already know from class that the first number in a set of coordinates represents the position of the point along the x-axis, and the second represents its position along the y-axis. So we know that point A is at 0, 5, 0 on the x-axis and 5 on the y-axis. We know that the final shape we create should be a square. What are some things we know about a square? Well, we know that a square is a quadrilateral, and so has 4 sides. In the case of a square, these 4 sides are equal in length, so we know that the distance between point A and point D is the same as the distance between point B and point A, point B and point C, and point D and point C. So we need to put point C in a position where it is the same distance away from points B and D. From simple observation, we can tell that to get to point A from point B, we must go 3 squares across and 4 squares up. The same general pattern applies for each point, however it may be reversed, so 4 across and 3 up or down. We can try applying both of these rules to point C. We already know that point C should be somewhere in this region, so we should try going 3 across and 4 up and 4 across and 3 up. We should be able to spot straight away where point C should actually lie. If we go 3 across and 4 up, we can see that point C would be closer to point D than it is to point B. We know that this is incorrect, as in a square all 4 vertices must be equal distances apart. However, if we go 4 across and 3 up, point C would be an equal distance away from both points B and D. We can even try drawing the square in to make sure that we put C in the right place. We can use the same law of coordinates we talked about before to know that C is at 7, 4. Thank you for watching. We hope you've been able to build on your knowledge of plotting coordinates and 2D shapes. If you have any questions, don't hesitate to leave a comment or reach out on our other platforms. Check out the other videos in the playlist for more solutions on tricky questions from this paper.